Chapter 1 of Book 4 of On the Heavens by Aristotle, translated by J. L. Stocks. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. We have now to consider the terms "heavy" and "light." We must ask what the bodies so called are, how they are constituted, and what is the reason of their possessing these powers. The consideration of these questions is a proper part of the theory of movement, since we call things heavy and light because they have the power of being moved naturally in a certain way. The activities corresponding to these powers have not been given any name, unless it is thought that 'impetus' is such a name. But because the inquiry into nature is concerned with movement, and these things have in themselves some spark, as it were, of movement, all inquirers avail themselves of these powers, though in all but a few cases without exact discrimination. We must then first look at whatever others have said, and formulate the questions which require settlement in the interests of this inquiry, before we go on to state our own view of the matter. Language recognizes (a) an absolute, (b) a relative, heavy and light. Of two heavy things, such as wood and bronze, we say that the one is relatively light, the other relatively heavy. Our predecessors have not dealt at all with the absolute use of the terms, but only with the relative. I mean, they do not explain what the heavy is, or what the light is, but only the relative heaviness and lightness of things possessing weight. This can be made clearer as follows. There are things whose constant nature it is to move away from the centre, while others move constantly towards the centre. And of these movements, that which is away from the centre I call upward movement, and that which is towards it I call downward movement. The view urged by some, that there is no up and no down in the heaven, is absurd. There can be, they say, no up and no down, since the universe is similar every way, and from any point on the earth's surface a man, by advancing far enough, will come to stand foot to foot with himself. But the extremity of the whole, which we call 'above', is in position above and in nature primary. And since the universe has an extremity and a centre, it must clearly have an up and down. Common usage is thus correct, though inadequate. And the reason of its inadequacy is that men think that the universe is not similar every way. They recognize only the hemisphere which is over us. But if they went on to think of the world as formed on this pattern all round, with a centre identically related to each point on the extremity, they would have to admit that the extremity was above and the centre below. By absolutely light, then, we mean that which moves upward or to the extremity, and by absolutely heavy, that which moves downward or to the centre. By lighter or relatively light, we mean that one, of two bodies endowed with weight and equal in bulk, which is exceeded by the other in the speed of its natural downward movement. Chapter 2. Those of our predecessors who have entered upon this inquiry have, for the most part, spoken of light and heavy things only in the sense in which one of two things, both endowed with weight, is said to be the lighter. And this treatment they consider a sufficient analysis also of the notions of absolute heaviness and absolute lightness, to which their account does not apply. This, however, will become clearer as we advance. One use of the terms 'lighter' and 'heavier' is that which is set forth in writing in the Timaeus, that the body which is composed of the greater number of identical parts is relatively heavy, while that which is composed of a smaller number is relatively light. as a larger quantity of lead or of bronze is heavier than a smaller, and this holds good of all homogeneous masses, the superior weight always depending upon a numerical superiority of equal parts. In precisely the same way they assert lead is heavier than wood. For all bodies, in spite of the general opinion to the contrary, are composed of identical parts and of a single material. But this analysis says nothing of the absolutely heavy and light. The facts are that fire is always light and moves upward, while earth and all earthy things move downwards or towards the centre. It cannot then be the fewness of the triangles, of which in their view all these bodies are composed, which disposes fire to move upward. If it were, the greater the quantity of fire, the slower it would move, owing to the increase of weight due to the increased number of triangles. But the palpable fact, on the contrary, is that the greater the quantity, the lighter the mass is, and the quicker its upward movement. And similarly, in the reverse movement from above downward, the small mass will move quicker and the large slower. Further, since to be lighter is to have fewer of these homogeneous parts, and to be heavier is to have more, and air, water, and fire are composed of the same triangles, the only difference being in the number of such parts, which must therefore explain any distinction of relatively light and heavy between these bodies, it follows that there must be a certain quantum of air which is heavier than water. But the facts are directly opposed to this. The larger the quantity of air, the more readily it moves upward, and any portion of air, without exception, will rise up out of the water. So much for one view of the distinction between light and heavy. To others the analysis seems insufficient, and their views on the subject, though they belong to an older generation than ours, have an air of novelty. It is apparent that there are bodies which, when smaller in bulk than others, yet exceed them in weight. It is therefore obviously insufficient to say that bodies of equal weight are composed of an equal number of primary parts, for that would give equality of bulk. Those who maintain that the primary or atomic parts, of which bodies endowed with weight are composed, are planes, cannot so speak without absurdity. But those who regard them as solids are in a better position to assert that of such bodies the larger is the heavier. But since in composite bodies the weight obviously does not correspond in this way to the bulk, the lesser bulk being often superior in weight, as for instance if one be wool and the other bronze, there are some who think and say that the cause is to be found elsewhere. The void, they say, which is imprisoned in bodies lightens them and sometimes makes the larger body the lighter. The reason is that there is more void. And this would also account for the fact that a body composed of a number of solid parts equal to, or even smaller than, that of another is sometimes larger in bulk than it. In short, generally, and in every case, a body is relatively light when it contains a relatively large amount of void. This is the way they put it themselves, but their account requires an addition. Relative lightness must depend not only on an excess of void, but also on a defect of solid. For if the ratio of solid to void exceeds a certain proportion, the relative lightness will disappear. Thus fire, they say, is the lightest of things just for this reason that it has the most void. But it would follow that a large mass of gold, as containing more void than a small mass of fire, is lighter than it, unless it also contains many times as much solid. The addition is therefore necessary. Of those who deny the existence of a void, some, like Anaxagoras and Empedocles, have not tried to analyze the notions of light and heavy at all, and those who, while still denying the existence of a void, have attempted this, have failed to explain why there are bodies which are absolutely heavy and light, or, in other words, why some move upward and others downward. The fact, again, that the body of greater bulk is sometimes lighter than smaller bodies is one which they have passed over in silence, and what they have said gives no obvious suggestion for reconciling their views with the observed facts. But those who attribute the lightness of fire to its containing so much void are necessarily involved in practically the same difficulties. For though fire be supposed to contain less solid than any other body, as well as more void, yet there will be a certain quantum of fire in which the amount of solid or plenum is in excess of the solids contained in some small quantity of earth. They may reply that there is an excess of void also, but the question is, how will they discriminate the absolutely heavy? Presumably either by its excess of solid or by its defect of void. On the former view, there could be an amount of earth so small as to contain less solid than a large mass of fire, and similarly, if the distinction rests on the amount of void, there will be a body lighter than the absolutely light, which nevertheless moves downward as constantly as the other moves upward. But that cannot be so, since the absolutely light is always lighter than bodies which have weight and move downward, while, on the other hand, that which is lighter need not be light, because in common speech we distinguish a lighter and a heavier, viz. Water and earth, among bodies endowed with weight. Again, the suggestion of a certain ratio between the void and the solid in a body is no more equal to solving the problem before us. This manner of speaking will issue in a similar impossibility, for any two portions of fire, small or great, will exhibit the same ratio of solid to void, but the upward movement of the greater is quicker than that of the less, just as the downward movement of a mass of gold or lead, or of any other body endowed with weight, is quicker in proportion to its size. This, however, should not be the case if the ratio is the ground of distinction between heavy things and light. There is also an absurdity in attributing the upward movement of bodies to a void, which does not itself move. If, however, it is the nature of a void to move upward, and of a plenum to move downward, and therefore each causes a like movement in other things, there was no need to raise the question why composite bodies are some light and some heavy. They had only to explain why these two things are themselves light and heavy respectively, and to give, further, the reason why the plenum and the void are not eternally separated. It is also unreasonable to imagine a place for the void, as if the void were not itself a kind of place. But if the void is to move, it must have a place out of which, and into which, the change carries it. Also, what is the cause of its movement? Not surely its voidness, for it is not the void only which is moved, but also the solid. Similar difficulties are involved in all other methods of distinction, whether they account for the relative lightness and heaviness of bodies by distinctions of size, or proceed on any other principle, so long as they attribute to each the same matter, or even if they recognize more than one matter, so long as that means only a pair of contraries. If there is a single matter, as with those who compose things of triangles, nothing can be absolutely heavy or light, and if there is one matter and its contrary, the void for instance and the plenum, no reason can be given for the relative lightness and heaviness of the bodies intermediate between the absolutely light and heavy when compared either with one another or with these themselves. The view which bases the distinction upon differences of size is more like a mere fiction than those previously mentioned, but in that it is able to make distinctions between the four elements, it is in a stronger position for meeting the foregoing difficulties. Since, however, it imagines that these bodies which differ in size are all made of one substance, it implies equally with the view that there is but one matter, that there is nothing absolutely light, and nothing which moves upward, except as being passed by other things or forced up by them. And since a multitude of small atoms are heavier than a few large ones, it will follow that much air or fire is heavier than a little water or earth, which is impossible. Chapter 3. These, then, are the views which have been advanced by others, and the terms in which they state them. We may begin our own statement by settling a question which to some has been the main difficulty: the question why some bodies move always and naturally upward, and others downward, while others again move both upward and downward. After that we will inquire into light and heavy, and the explanation of the various phenomena connected with them. The local movement of each body into its own place must be regarded as similar to what happens in connexion with other forms of generation and change. There are, in fact, three kinds of movement, affecting respectively the size, the form, and the place of a thing, and in each it is observable that change proceeds from a contrary to a contrary, or to something intermediate. It is never the change of any chance subject in any chance direction, nor, similarly, is the relation of the mover to its object fortuitous. The thing altered is different from the thing increased, and precisely the same difference holds between that which produces alteration and that which produces increase. In the same manner it must be thought that that which produces local motion and that which is so moved are not fortuitously related. Now, that which produces upward and downward movement is that which produces weight and lightness, and that which is moved is that which is potentially heavy or light, and the movement of each body to its own place is motion towards its own form. It is best to interpret in this sense the common statement of the older writers that like moves to like, for the words are not in every sense true to fact. If one were to remove the earth to where the moon now is, the various fragments of earth would each move not towards it, but to the place in which it now is. In general, when a number of similar and undifferentiated bodies are moved with the same motion, this result is necessarily produced, viz. That the place which is the natural goal of the movement of each single part is also that of the whole. But since the place of a thing is the boundary of that which contains it, and the continent of all things that move upward or downward is the extremity and the centre, and this boundary comes to be, in a sense, the form of that which is contained, it is to its like that a body moves when it moves to its own place. For the successive members of the series are like one another. Water, I mean, is like air, and air like fire, and between intermediates the relation may be converted, though not between them and the extremes. Thus air is like water, but water is like earth, for the relation of each outer body to that which is next within it is that of form to matter. Thus, to ask why fire moves upward and earth downward is the same as to ask why the healable, when moved and changed qua healable, attains health and not whiteness. And similar questions might be asked concerning any other subject of alteration. Of course, the subject of increase, when changed qua increasable, attains not health, but a superior size. The same applies in the other cases. One thing changes in quality, another in quantity, and so in place a light thing goes upward, a heavy thing downward. The only difference is that in the last case, viz. That of the heavy and the light, the bodies are thought to have a spring of change within themselves, while the subjects of healing and increase are thought to be moved purely from without. Sometimes, however, even they change of themselves, i.e., in response to a slight external movement, reach health or increase, as the case may be. And since the same thing which is healable is also receptive of disease, it depends on whether it is moved qua healable or qua liable to disease, whether the motion is towards health or towards disease. But the reason why the heavy and the light appear more than these things to contain within themselves the source of their movements is that their matter is nearest to being. This is indicated by the fact that locomotion belongs to bodies only when isolated from other bodies, and is generated last of the several kinds of movement. In order of being, then, it will be first. Now, whenever air comes into being out of water, light out of heavy, it goes to the upper place. It is forthwith light. Becoming is at an end, and in that place it has being. Obviously, then, it is a potentiality which, in its passage to actuality, comes into that place and quantity and quality which belong to its actuality. And the same fact explains why what is already actually fire or earth moves, when nothing obstructs it, towards its own place. For motion is equally immediate in the case of nutriment, when nothing hinders, and in the case of the thing healed, when nothing stays the healing. But the movement is also due to the original creative force, and to that which removes the hindrance, or off which the moving thing rebounded, as was explained in our opening discussions, where we tried to show how none of these things moves itself. The reason of the various motions of the various bodies, and the meaning of the motion of a body to its own place, have now been explained. End of Chapter 3. Recording in memory of Mitchell Edwards. Chapter 4 of Book 4 of On the Heavens by Aristotle. Translated by J.L. Stocks. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 4. We have now to speak of the distinctive properties of these bodies, and of the various phenomena connected with them. In accordance with general conviction, we may distinguish the absolutely heavy as that which sinks to the bottom of all things, from the absolutely light, which is that which rises to the surface of all things. I use the term 'absolutely' in view of the generic character of 'light' and 'heavy', in order to confine the application to bodies which do not combine lightness and heaviness. It is apparent, I mean, that fire, in whatever quantity, so long as there is no external obstacle, moves upward, and earth downward, and if the quantity is increased, the movement is the same, though swifter. But the heaviness and lightness of bodies which combine these qualities is different from this, since while they rise to the surface of some bodies, they sink to the bottom of others. Such are air and water. Neither of them is absolutely either light or heavy. Both are lighter than earth, for any portion of either rises to the surface of it, but heavier than fire, since a portion of either, whatever its quantity, sinks to the bottom of fire. Compared together, however, the one has absolute weight, the other absolute lightness, since air in any quantity rises to the surface of water, while water in any quantity sinks to the bottom of air. Now, other bodies are severally light and heavy, and evidently in them the attributes are due to the difference of their uncompounded parts. That is to say, according as the one or the other happens to preponderate, the bodies will be heavy and light respectively. Therefore, we need only speak of these parts, since they are primary, and all else consequential. And in so doing, we shall be following the advice which we gave to those who attribute heaviness to the presence of plenum, and lightness to that of void. It is due to the properties of the elementary bodies that a body which is regarded as light in one place is regarded as heavy in another, and vice versa. In air, for instance, a talent's weight of wood is heavier than a mina of lead, but in water the wood is the lighter. The reason is that all the elements except fire have weight, and all but earth lightness. Earth, then, and bodies in which earth preponderates must needs have weight everywhere, while water is heavy anywhere but in earth, and air is heavy when not in water or earth. In its own place each of these bodies has weight except fire, even air. Of this we have evidence in the fact that a bladder when inflated weighs more than when empty. A body, then, in which air preponderates over earth and water may well be lighter than something in water, and yet heavier than it in air, since such a body does not rise in air, but rises to the surface in water. The following account will make it plain that there is an absolutely light and an absolutely heavy body, and by absolutely light I mean one which of its own nature always moves upward, by absolutely heavy one which of its own nature always moves downward, if no obstacle is in the way. There are, I say, these two kinds of body, and it is not the case, as some maintain, that all bodies have weight. Different views are in fact agreed that there is a heavy body which moves uniformly towards the centre, but there is also similarly a light body. For we see with our eyes, as we said before, that earthy things sink to the bottom of all things and move towards the centre, but the centre is a fixed point. If, therefore, there is some body which rises to the surface of all things, and we observe fire to move upward even in air itself, while the air remains at rest, clearly this body is moving towards the extremity. It cannot then have any weight. If it had, there would be another body in which it sank, and if that had weight, there would be yet another which moved to the extremity, and thus rose to the surface of all moving things. In fact, however, we have no evidence of such a body. Fire, then, has no weight. Neither has earth any lightness, since it sinks to the bottom of all things, and that which sinks moves to the centre. That there is a centre towards which the motion of heavy things, and away from which that of light things is directed, is manifest in many ways. First, because no movement can continue to infinity. For what cannot be can no more come to be than be, and movement is a coming to be in one place from another. Secondly, like the upward movement of fire, the downward movement of earth and all heavy things makes equal angles on every side with the earth's surface. It must therefore be directed towards the centre. Whether it is really the centre of the earth and not rather that of the whole to which it moves, may be left to another inquiry, since these are coincident. But since that which sinks to the bottom of all things moves to the centre, necessarily that which rises to the surface moves to the extremity of the region in which the movement of these bodies takes place. For the centre is opposed as contrary to the extremity, as that which sinks is opposed to that which rises to the surface. This also gives a reasonable ground for the duality of heavy and light in the spatial duality centre and extremity. Now there is also the intermediate region to which each name is given in opposition to the other extreme. For that which is intermediate between the two is in a sense both extremity and centre. For this reason there is another heavy and light, namely water and air. But in our view the continent pertains to form and the contained to matter, and this distinction is present in every genus. Alike in the sphere of quality and in that of quantity, there is that which corresponds rather to form, and that which corresponds to matter. In the same way, among spatial distinctions, the above belongs to the determinate, the below to matter. The same holds, consequently, also of the matter itself of that which is heavy and light, as potentially possessing the one character it is matter for the heavy, and as potentially possessing the other for the light. It is the same matter, but its being is different, as that which is receptive of disease is the same as that which is receptive of health, though in being different from it, and therefore diseasedness is different from healthiness. Chapter 5. A thing, then, which has the one kind of matter is light and always moves upward, while a thing which has the opposite matter is heavy and always moves downward. Bodies composed of kinds of matter different from these, but having relatively to each other the character which these have absolutely, possess both the upward and the downward motion. Hence air and water each have both lightness and weight, and water sinks to the bottom of all things except earth, while air rises to the surface of all things except fire. But since there is one body only which rises to the surface of all things, and one only which sinks to the bottom of all things, there must needs be two other bodies which sink in some bodies and rise to the surface of others. The kinds of matter, then, must be as numerous as these bodies, i.e. 4. But though they are 4, there must be a common matter of all, particularly if they pass into one another, which in each is in being different. There is no reason why there should not be one or more intermediates between the contraries, as in the case of colour, for 'intermediate' and 'mean' are capable of more than one application. Now, in its own place, every body endowed with both weight and lightness has weight, whereas earth has weight everywhere, but they only have lightness among bodies to whose surface they rise. Hence, when a support is withdrawn, such a body moves downward until it reaches the body next below it, air to the place of water, and water to that of earth. But if the fire above air is removed, it will not move upward to the place of fire, except by constraint. And in that way water also may be drawn up, when the upward movement of air, which has had a common surface with it, is swift enough to overpower the downward impulse of the water. Nor does water move upward to the place of air, except in the manner just described. Earth is not so affected at all, because a common surface is not possible to it. Hence water is drawn up into the vessel to which fire is applied, but not earth. As earth fails to move upward, so fire fails to move downward when air is withdrawn from beneath it. For fire has no weight even in its own place, as earth has no lightness. The other two move downward when the body beneath is withdrawn, because, while the absolutely heavy is that which sinks to the bottom of all things, the relatively heavy sinks to its own place, or to the surface of the body in which it rises, since it is similar in matter to it. It is plain that one must suppose as many distinct species of matter as there are bodies. For if, first, there is a single matter of all things, as for instance the void, or the plenum, or extension, or the triangles, either all things will move upward, or all things will move downward, and the second motion will be abolished. And so either there will be no absolutely light body, if superiority of weight is due to superior size, or number of the constituent bodies, or to the fullness of the body, but the contrary is a matter of observation, and it has been shown that the downward and upward movements are equally constant and universal. Or if the matter in question is the void, or something similar, which moves uniformly upward, there will be nothing to move uniformly downward. Further, it will follow that the intermediate bodies move downward in some cases quicker than earth, for air in sufficiently large quantity will contain a large number of triangles, or solids, or particles. It is, however, manifest that no portion of air whatever moves downward, and the same reasoning applies to lightness, if that is supposed to depend on superiority of quantity of matter. But if, secondly, the kinds of matter are two, it will be difficult to make the intermediate bodies behave as air and water behave. Suppose, for example, that the two asserted are void and plenum. Fire, then, as moving upward, will be void, earth, as moving downward, plenum, and in air it will be said fire preponderates, in water, earth. There will then be a quantity of water containing more fire than a little air, and a large amount of air will contain more earth than a little water. Consequently, we shall have to say that air in a certain quantity moves downward more quickly than a little water. But such a thing has never been observed anywhere. Necessarily, then, as fire goes up because it has something, e.g. void, which other things do not have, and earth goes downward because it has plenum, so air goes to its own place above water because it has something else, and water goes downward because of some special kind of body. But if the two bodies are one matter, or two matters both present in each, there will be a certain quantity of each at which water will excel a little air in the upward movement, and air excel water in the downward movement, as we have already often said. Chapter 6. The shape of bodies will not account for their moving upward or downward in general, though it will account for their moving faster or slower. The reasons for this are not difficult to see. For the problem thus raised is why a flat piece of iron or lead floats upon water, while smaller and less heavy things, so long as they are round or long, a needle for instance, sink down, and sometimes a thing floats because it is small, as with gold dust and the various earthy and dusty materials which throng the air. With regard to these questions, it is wrong to accept the explanation offered by Democritus. He says that the warm bodies moving up out of the water hold up heavy bodies which are broad, while the narrow ones fall through because the bodies which offer this resistance are not numerous. But this would be even more likely to happen in air, an objection which he himself raises. His reply to the objection is feeble. In the air, he says, the drive, meaning by drive the movement of the upward moving bodies, is not uniform in direction. But since some continua are easily divided and others less easily, and things which produce division differ similarly in the ease with which they produce it, the explanation must be found in this fact. It is the easily bounded, in proportion as it is easily bounded, which is easily divided, and air is more so than water, water than earth. Further, the smaller the quantity in each kind, the more easily it is divided and disrupted. Thus the reason why broad things keep their place is because they cover so wide a surface, and the greater quantity is less easily disrupted. Bodies of the opposite shape sink down because they occupy so little of the surface, which is therefore easily parted. And these considerations apply with far greater force to air, since it is so much more easily divided than water. But since there are two factors, the force responsible for the downward motion of the heavy body, and the disruption resisting force of the continuous surface, there must be some ratio between the two. For in proportion as the force applied by the heavy thing towards disruption and division exceeds that which resides in the continuum, the quicker will it force its way down. Only if the force of the heavy thing is the weaker will it ride upon the surface. We have now finished our examination of the heavy and the light, and of the phenomena connected with them. End of chapter 6. End of book 4. And end of On the Heavens by Aristotle, translated by J.L. Stocks. Read by Geoffrey Edwards. Proof listened by Caelo. Meta-coordinated by Joe. Recording in memory of Mitchell Edwards.